Welcome to another video. In this video, I will be finding the derivative of an inverse trig function, particularly inverse sine, from the definition of the derivative. So we'll be using the first principles definition. So I don't want to make this a long video, so let's just start. The first thing I need you to know is that you have to recall your trig functions and your trig identities, and you have to also recall at least the definition of the derivative. So let's write it. We know that the definition f prime of x is equal to the limit as h goes to 0 of, in this case, it's going to be arcsine of x plus h minus arcsine of x divided by h. So remember, it's f of x plus h minus f of x over h. So I already used the function since my f of x is arcsine of x. So now this is where I want to do some work because we have to do some manipulations. The first thing is that we do not know, at least I do not know of any trig identity that uses arcsine. Okay, so there is no angle sum or angle difference or whatever, or double angle, all that, because this is inverse, okay? It's the inverse function of a trig. So what I'm going to do is try and manipulate what the argument is so that I can get something that I can work with. So what if we make these assumptions or substitutions and say, let's take this first part, okay? Why do we want to do this? Remember that the inverse of a function gives you the argument. If you put the output back into the inverse function, you get the original input. That's the definition of the inverse functions. One undoes the other, okay? So that's what I'm going to do. I'm going to make this a function that this arcsine can undo. So let's do this. Let x plus h be equal to sine a, which means if I put sine a here, which implies that arcsine of, instead of writing x plus h, I'm going to write sine a, is just going to give me a. So what I'm going to have here now is just going to be a, but I know what a is. A is the argument that gives me x plus h. Okay, the same thing, I'm going to say let x be equal to sine b, which means that the arcsine of sine b is going to be just b. So the function I have is just a minus b on top. But I want to replace this h. I don't want this h to show up. So I go back here and say h is equal to sine a. If you isolate h from here, it's going to move this x over. It's going to be sine a minus x. But what did we say x is? We said x is sine b. So this is just the only part you need to pay attention to and see what happens. As h goes to 0, we can actually say that sine a goes to sine b. As this approaches 0, this will approach this because that's the only way this will become 0, so that when you subtract them, you get 0. Okay? And you can actually say if sine a is approaching sine b, then a is approaching b. Okay? It's the same function. If sine a is approaching sine b, it's like saying if f of a is approaching f of b, definitely a is approaching b, unless it's a weird function, but they're approaching each other. Whether from the same side or from different sides, they are approaching each other because you're going to the same thing. Okay? So here we'll say that sine a is approaching sine b, which also implies that a is approaching b. Do you see that? So basically, this is what we're going to get. So yeah, it's either you say a is approaching b or you say a minus b is approaching 0. So I'm going to replace everything in this formula and write it this way. F prime of x is equal to the limit as a minus b. As a approaches b, you can put it that way, or a minus b approaches 0, of the top is now going to be a, and this side is going to be minus b, and under what I'm going to have is h. What did we say h was again? Sine a minus sine b. And this is what we need to work with. Everybody can do this now that we know what we're doing. So now we need an identity to change this guy because there's nothing we can do with this. What we have is 0 over 0. You have to do algebra or trig. So look at sine A minus sine B. This is an identity you learned in trig. And let me bring it back to your memory. I want you to recall that there was an identity like this. Sine A minus sine B is equal to 2 multiplied by the cosine of the sum divided by 2 multiplied by the sine of the difference over 2. Now, can you do this another way? I don't know another way. You have to remember that you can replace this identity because now we can do some limits with this product. So look at this. I'm going to replace this. So what we have here, let's put this in a box. Okay, so what we have here is the limit as A minus B goes to 0 of, it's going to be now A minus B. You can see A minus B is here, so your attention should be here because what we're trying to get rid of is this A minus B. And so you want to pay attention to this. But A minus B is what you have here, but what you have under is A minus B over 2. So there's some extra manipulation you need to do. So at this point, it's A minus B over, this is going to be, instead of writing sine A minus sine B, we write 2 cosine A plus B over 2 sine A minus B over 2. So that's what we've got. There's a limit I'm planning to use, so I have to do the manipulation. I want to be able to generate something that looks like this. The limit as x goes to 0 of x over sine x equals 1. As long as what's on top is what's the argument of sine, and that same thing is going to 0, then you're good. Okay? So what we want to do is make sure that this is not just A minus B, it becomes A minus B over 2, so that we can put it on top of this and say this whole expression, if this is divided by 2, will go to 0. And I can make this go to 0. How do I do it? What I'm going to do is I'm going to divide this by 2. But because I've divided this by 2, I have to also multiply it by 2. Oh, I can put the 2 here. Actually, let's do it that way. So this 2 cancels these 2 out, but I need to use this. So see what my next line is going to be. It's going to be the limit. I still want to do A minus B goes to 0. As A minus B approaches 0, let me put this in parentheses, of, now see it's going to be 2 over, here it's going to be 2 cosine A plus B over 2 multiplied by A minus B over 2 divided by sine A minus B over 2. Now, almost at the end, as A approaches B, as A minus B goes to 0, this expression will go to 1. So I can actually multiply this by 1. That's the limit. And here, as A minus B goes to 0, it means A is approaching B. As A approaches B, it means A becomes B eventually. So what we have here is going to be 2 over 2 cosine B plus B over 2. You see that? And this 2 cancels this 2. Our answer is going to be 1 over cosine 2b over 2, which is basically cosine b. Oh, that's our final answer. But you remember, we want to write our answer in terms of x because you're looking for the inverse function. So how can we get this? We don't have cosine. At the beginning, we had sine. Oh, we had sine b. So sine b is x. So what we're going to do is, it's either you use the triangle. So you could actually use the triangle, construct a triangle, and make this angle b. So sine b is opposite over hypotenuse, so that's going to be opposite, that's x over 1. And then this is going to be 1 minus x squared square root. And then you can find cosine b. See, cosine b is adjacent over hypotenuse, so you can put that down here and you're fine with your answer. Or you can use another trig identity. We know that this is equal to, from here, 1 over, what is cosine b? Cosine b is the square root of cosine squared b, so that's the square root of cosine squared b, which is equal to 1 over the square root of 1 minus sine squared b, which we know sine b was x. So this is equal to 1 over the square root of 1 minus x squared. This is the derivative of the arcsine of x from the first principles. Hope you learned something. The same applies for all the other ones. In other videos I might do this, but if you want to just do it, this is the process. Remember the relevant identity and do this. Never stop learning, because those who stop learning have stopped living. Bye-bye.